Hello, my name is Luis Molina. In this video, I will compare two important computer architectures, von Neumann and Herbert. I will explain how they work, their advantage and disadvantage, and I'll show you a practical example using von Neumann simulators. The von Neumann architecture was created by the scientist John von Neumann in the 1940s. In this model, both instruction and data are stored in the same memory. This makes it simple and cheaper, but it also creates what is known as the von Neumann bottleneck, because the processor can only fetch one thing at the time, either an instruction or a piece of data. Because of this, the CPU sometimes has to wait, and that slows down the execution. So let's see a simple example in the simulator. Here using two variables, x and y, with the values 6 and 7 in the variables. Also, I also set the rest of the memory set in zero. In the temporary register T0 and T1, I place the value 8 in both. This means the program will multiply or work with those values depending on the instruction we give it. When we start the simulation, the processor begins reading from memory. Remember, in this architecture, both the instruction and the data are stored together in the same memory. So we execute step by step. So I start the simulation. The CPU fetch an instruction, for example, load x. Then it reads the value of x, which it sits from the same memory area. Next, it may load g, load y, or one of the temporary register T0 or T1 with the value of 8. The result of any operation is stored again in the memory. So it's finishing the simulation. Yeah, it's ready. You can actually see how both the program code and the data values sit 7 and 8 together in the same memory table. This clearly demonstrates the main characteristic of this architecture. Well, now the Harvard architecture works in a different way. It has two separate memories, one of instruction and another for data. This means the CPU can read a program instruction and a piece of data at the same time, which makes it faster and more efficient than the von Neumann model. The Harvard model is commonly used in microcontrollers and digital signal processors, where performance is more important than simplicity. However, this also means it's more complex and more expensive to design. For example, when multiplying two numbers like 6 and 7, the CPU in Harvard system can read the instruction multiply from one memory and the numbers 6 and 7 from another memory in the same time. That's why it's faster. So, for comparison between both architecture, its memory, von Neumann is in the same memory space, Harvard no. Speed Von Neumann is slower than Harvard. Complexity, von Neumann is simple design and Harvard is more complex design. Cost, von Neumann is cheaper than Harvard architecture. An example of use, von Neumann in general computers, Harvard in microcontrollers. Conclusion, the von Neumann architecture is simple and cheaper, but is slower. The Harvard architecture is faster, but more complex and costly than von Neumann architecture. Thank you.